Hello, so this is my final exam on astronomy, and throughout this semester, I was really caught interest in questions about life in the universe and how we study distant galaxies. So for my intro, all these topics kind of go in hand to what I was curious in this semester, and all three of these deal with life beyond Earth and also how we search for it using powerful space tools. So first topic that we're going to talk about is the Drake equation, which I'll go into detail later. And a brief summary is this: it just estimates alien civilization, and it's a mathematical formula. The next one is the Fermi paradox, which raises the question why we haven't found aliens. And for the third topic, it's the Hubble telescope, which is a space tool that's used to see deep into space. So it sits on the Earth's atmosphere. So for the Drake equation, what is it? It's a mathematical formula that collects the data and the number of civilizations in the Milky Way galaxy whose electromagnetic emissions are detectable. So going through each letter in our formula, N stands for the number of civilizations that we were able to communicate with. R is the rate of formation of stars, so how quickly and rapidly the stars are forming. The FP is for the fraction of the stars that have planetary systems. NE is how many planets there are per solar system with an environment that is suitable for life. The F is for the fraction of suitable planets of which life actually appears. The other FI is the fraction of life-bearing planets on which intelligence is able to emerge. FC is a fraction of those planets with intelligent life that help develop interstellar communication. And L is the length of time that the civilizations have and are able to release detectable signals into space. Now we have the Fermi paradox. What is it? It's the contradiction between high chances of alien life and the fact that we haven't seen or heard from any of it. So it's the idea that there still might be extraterrestrial life out there, but there's no signs of its existence. These are the three main hypotheses and more popular ones explained. So first is the greater filter hypothesis. So what it is the idea that there's a step in the development of intelligent life that's extremely hard to survive. So this is the idea that maybe we've already passed it, or maybe it's in the future, which could possibly lead to self-destruction. The next one is the zoo hypothesis. This is the idea that advanced alien civilizations know that we exist and know that we're here, but they're deliberately choosing not to make contact with us, and they're sort of surrounding us and watching us as if like a zoo, as we watch animals like monkeys, gorillas. That's what we're envisioned as. So we're to the monkeys as the extraterrestrial is to us. The last theory is the we're truly alone theory. So this idea is that maybe there isn't actually intelligent life out there, and that it's actually much rarer than we think. And this could be a good thing that we're lucky that we're the only ones in the galaxy, or it's a bad thing that we're the only ones in the universe. In astronomy, concluding all of these hypotheses, this kind of gives me the question of where are we in our galaxy? And it made me kind of think where we are in our universe, and if we're as strong as maybe other extraterrestrial life there is, and if it's safe for us to try and go out there and look for them, because we don't know how powerful they are. The next lesson is the Hubble telescope and kind of our eyes in space. So it was launched by NASA in 1990, and it's still going on throughout today. And the idea of this was to help capture images of galaxies, stars, and planets, and using them help measure the age and expansion of the universe. So this space tool has really helped us a lot and helped lead to discoveries of exoplanets and dark energy and many others. Throughout this tool, we've been able to capture images that we haven't been able to capture ever before prior to this Hubble telescope. It orbits above Earth's atmosphere for clearer views, and in the next slide you'll see the images and how well it has captured them. So what has Hubble shown us? The three kind of more popular and more beautiful ones in my opinion are the Pillar of Creation, the Sombrero Galaxy, and the Hubble Deep Field. For the Pillar of Creation, it's a massive star forming region in the Eagle Nebula, and just to get a zoom in here, look how beautiful that looks. That is an amazing image with all the lights in the background, the stars, the other galaxies. That's beautiful. The next one is the Sombrero Galaxy, and this is just a spiral galaxy that looks like a sombrero in the universe, and yeah, it looks amazing to look at. It sort of looks like a giant cosmic hat. And then we have the Hubble Deep Field, which is just a tiny patch of sky filled with thousands of galaxies, which is insane. And I feel like this Hubble image really puts into perspective how big our universe really is. With the help of the Hubble, it kind of showed how stars are formed, and it also showed scientists how far some galaxies are from us. With the Hubble, it just created very detailed images, as you can see, and prior to the Hubble being launched, we were not able to get images like this, of this clearness of it and deep into the universe. So moving on, how these topics are all connected. So they all play into the part of humanity's biggest question, which is, are we alone in the universe? The way I see it is the Drake equation and the Fermi paradox help us ask why, and the Hubble telescope helps us see and try to answer that question of why. So the Drake equation, like I said, estimates how many alien civilizations might exist. The Fermi paradox asks why we haven't found any, even though they seem likely. And the Hubble telescope kind of helps us answer these by exploring the universe and searching for signs of life. And now moving on to the favorite thing I've learned. So throughout this year, we've learned some very interesting things, but I think my favorite is the space tool of the Hubble and the images that were able to be captured by it. So one of my more favorite ones, it may not be the prettiest one, but it was the Hubble Deep Field. And this is because it put in perspective how big the galaxies are. The image that was taken was just a tiny patch of the sky, and it showed thousands of galaxies. So let me go back to that image so you can see. This is the one I'm talking about. So this is just a small patch of the sky, and all these little lights are thousands of galaxies. And I think this is my favorite part because of all the other images it created and how advanced we were able to become once the Hubble was launched, because it was able to capture the universe. And I just think that helped us a lot, and it will continue to help us in the future, especially for considering to look for extraterrestrial life. So these are the websites I use: nasa.gov, space.com, the hubblesite.org, which was very informative, and the Fermi paradox, which just put into detail about what it really was. And now the self-evaluation of my presentation. So some of the strengths I felt I had was these were very complex ideas, and I felt putting them into my own words kind of helped simplify them and sort of necessary and kind of dumb them down, which I felt helps people understand better what I'm talking about, because I know astronomy can be very confusing at times because some people may not know the proper vocabulary. So I felt me putting them into my own words kind of helped create a better understanding for others. And I felt like the images I chose on my slideshow were very high quality, such as the Hubble images. I feel like these images that I attached captured very well how great the Hubble is. And now some of the weakness, I felt like I could have added maybe an animation or more transitions to make this look cooler. And I needed better time management for narration. So I feel like I'm kind of rushing myself when I could be talking more slow and relaxed. So the reflection on the course and my conclusion. So one of the main things I enjoyed throughout this year was learning about life that was beyond the Earth, and the ability to use real science tools like the Hubble, as I mentioned prior. And the other two topics I chose were my more favorite topics learned, which is like the Fermi paradox and the Drake equation. And I felt this year was great. I feel like you did a great job teaching us, and I felt I have a way better understanding of astronomy, and it's actually grown my interest in astronomy after this class. So I don't think I have very many suggestions, or if any suggestions, but if I had to say something, I'd say more hands-on activities. I feel like our idea of the rocket and how we made the class even more engaging, but I felt like overall we had a great year. And I want to say thank you for your time and helping me find an interest in astronomy, because I really didn't know if I was going to like it or not. But after this class, I really feel like I have. So that's the end of my presentation, and thank you, sir. Hope you have a great rest of your year.